Hi, welcome to my video presentation on microgrids. We'll learn a bit about what a microgrid is, some benefits and issues facing microgrids, and a brief look at a proposed microgrid. What is a microgrid? Let's start off by thinking about our standard power grid with lots of generation, loads, and transmission lines. Now picture a smaller and scaled down version of that grid. The microgrid usually operates at distribution level. This is typically 12 kilovolts or 25 kilovolts at primary distribution levels in BC, with local generation, local loads, and distribution lines. It is essentially a grid of its own. An IEEE paper dated in 2001 has suggested the definition of a small source be less than 500 kilowatts. Oftentimes, individual distributed generation sources are smaller for this application, and other times they may be aggregated to produce over 500 kilowatts, like many test subjects in the United States. The main thing that defines a microgrid is its ability to operate connected or disconnected with the grid. The main benefit of microgrids is the money saved from not having to build expensive generation and transmission infrastructure to keep up with the growing energy demand. Most microgrids use renewable forms of energy and tries to implement combined heat and power to increase efficiency. Other benefits include increase in power reliability, reduction in energy losses, elimination of central dispatch, and the ability to serve as backup power for some area electric power system loads. There are 7 basic types of microgrids that are defined based on the level at which the microgrid is isolated from the rest of the system. The 7 types of microgrids are the local EPS island, also known as the facility island, which is circled near the top middle of the diagram. Next, you have the secondary island, which is in the gray rectangle to the left of the facility island. Then you have the lateral island in the brown rectangle underneath the facility island. The distribution circuit island in purple boundaries. The substation bus island in the red boundaries, the substation island in the green boundaries, and the adjacent circuit island in the green boundaries plus the semicircle on the right. As you can see, for each of these island definitions, it is defined by the circuit breaker or reclosure which opens, which connects or disconnects the island with the macrogrid. There is a focus on the point of common coupling to ensure safe interconnection to the grid. Unlike traditional distribution systems, microgrids should provide bidirectional power flow in order to be able to buy or sell power. Microgrids also have a rather unique protection scheme. The 4 main components of microgrids are distributed resource. This includes generation and storage, loads, power electronics, and protection elements. Power electronics are particularly important because they must clean dirty AC power or they convert DC to AC. This allows the microgrid to connect to the macrogrid. However, there are issues. Distributed generation is not always cost efficient. Energy storage is also not up to par. This is particularly an issue because intermittent intermittent sources like wind and solar power are unreliable. There are also a number of complexities when dealing with faults in the microgrid. Inverters are limited to 1 to 1.2 times its max load carrying current, which is not high enough to trip relays. Fault currents are smaller in island mode since the production of fault currents is limited to the microgrid. One consideration is to use energy storage systems to feed additional fault current in order to trip relays in a timely fashion. The use of digital relays is important for the development of microgrids because they can communicate. Digital relays communicate using the EECE 61850 standard to compare measurements with other relays rather than trip at certain settings, like traditional electromechanical relays. They can compare measurements such as phase and sequence voltage, current, impedance, frequency. Digital relays also have a delay of only 4 milliseconds or a quarter cycle, which is also significantly lower than its electromechanical counterpart. Now we'll talk briefly about the BCIT microgrid project. Currently, there is an AFresh home that functions as a microgrid with photovoltaic cells, fuel cell, inverter, and methods of control. Power quality and inverter capabilities are among the things currently being tested. Other features of the AFresh home include smart appliances, as seen in the picture, other green technologies, and also includes a vehicle to grid plug. The BCIT project is going to extend to the entire campus. They plan to use a PV system, an environment-friendly boiler, a biofuel boiler, and possibly a microturbine. The campus is well situated to conduct research since they have various load profiles on the campus to test from. This includes a machine shop with large machinery, a welding shop with transformers, standard campus loads such as classrooms and offices and cafeterias, and residential loads at the dormitories. In conclusion, microgrids are a fairly new concept, so as standards are being developed and as microgrid components become more proficient, we will see microgrids in the future. And that concludes my presentation for microgrids. Thank you very much for taking in the last thing I'll ever do for my undergrad. Bye-bye.